Hi friends, I am Mr. Sanjay Lakshmana Gaikwad, working as an assistant professor, also head of the department, Mahatma Phule Arts, Science and Commerce College, Panvel, District Raigad. Today we discuss on the topic nuclear reaction. Nuclear reaction. And this is a topic from the paper number 2, Modern Physics, unit number 2, and in that second chapter is the nuclear reactions. Like in chemistry, chemical reaction, in physics, the nuclear reaction is one of the chapter. This is syllabus of the unit number 2, in which first topic was the nuclear detector. We already discussed all that, and I already prepared the one of the PPT and video and shared on the YouTube channel. Okay. Now today we discuss on the nuclear reactions and the nuclear reaction. The articles of the syllabus are introduction, second the types of the nuclear reaction, third is the conservation laws related to the mass, energy and charge, then concept of the component direct reaction. There is an important, that is the for nuclear reaction there is a Q equation, Q value equation, and what is the Q we will discuss, and the Q value equation, addition to that there is a solution of Q equation. Remember that we want to discuss after that the solution of the Q equation, and addition to that we want to discuss on the threshold energy. Okay, these are the articles we want to discuss in chapter number 2. Today part of the syllabus, that is the introduction and types of the nuclear reaction and conservation laws, we will discuss today. Okay, from paper number 2, unit number 2, chapter number 2, that is the nuclear reactions, and in that today we will discuss on the introduction, types of nuclear reactions and conservation laws. And for that we want to use the reference book as this ESBP and the corresponding article. Generally friends, reference book is very good for the syllabus to understand the subject in deep, and there are the textbook also available in the market like SET publication, which is useful for the actual syllabus which is mentioned by the university. See, in nuclear reaction, already I discussed here that what is the syllabus for the chapter number 2. This is the second chapter, remember that. Okay, and these are the article from the reference book, and the author, the main reference book is the ESBP, that is the S.B. Patel book, related to the name of the book is Nuclear Physics and Introduction, and we want to use the second edition for the refer the articles. Okay, and textbook also available in the market to understand. Those students who are afraid about the physics, they can go through the SET publication. It is sufficient for understanding. If you are interested in the physics, then please go through these books. S.B. Patel, you can go through the Arthur Basel. Arthur Basel is one of the best book for understanding of the physics. Okay, remember that this is also good book, Arthur Basel. Next, introduction. In 1990, सुरुवातीला at the initial stage in 1990, Rutherford performed the experiment on nuclei of the nitrogen, and bombarding the alpha particle, and what happened, it gives when the, see here is some correction there, it should be 2. Okay, when helium nucleus bombarded on the nitrogen, it get combined and become the fluorine. This is the unstable nucleus. This is the unstable nucleus. Then again split into the oxygen 8 plus 1 proton. Means proton is initiated or the generated in this nuclear reaction. This is performed by the Rutherford, and it is experimentally shown by the Rutherford. Okay, remember that this is the first successfully completed reaction in the laboratory. This is the first reaction which is completed successfully in the laboratory. In 1932, the Cockcroft and Walton, they also used the artificial accelerator proton. Means this proton is accelerated with the help of the high energy external energy, and proton is accelerated with high energy and bombarded on the lithium nucleus. It bombarded on the lithium, and what happened, due to the interaction with the proton and lithium, it become new nucleus, that is the barium, which is also again unstable, and after breakdown of this barium, we can get the two separate alpha particles. This is reaction also made by completed by this in 1932 by Cockcroft and Walton with the help of artificial accelerated proton. Means by the external energy, hydrogen has proton is accelerated with high energy and is bombarded on the lithium. What was that energy? That energy was 0.1 to 0.7 million electron volt. Very high energy used to accelerate the proton, and after that it is bombarded on the lithium, and due to the interaction with the lithium it get absorbed by the lithium and become barium, but it is unstable. After that it split into the two alpha particles. This is another reaction. Now, nuclear reaction, just like a chemical reaction, here also the types of the nuclear reaction. Here also different types of nuclear reactions are there. J.M. Bhatt and V.F. Westcott give the classification of the nuclear reaction based on the nature of the projectile, energy and weight of the target nucleus. According to the projectiles, energy and atomic weight of the target nucleus, these two scientists classify the nuclear reaction or types of nuclear reactions given by these two scientists. One is the scattering reaction. First is the scattering reaction. This is a very important. This is the first type of nuclear reaction, that is scattering reaction. In this reaction, we have two types. Elastic and inelastic. First of all, I want to mention here that if we are going to represent any reaction, we use the format like that. X plus capital X means this X is nothing but the projectile. This is the target nucleus. And what happened? Their product is formed and addition part is the project particle. This is small x is the projectile, which is very small one, and it is a light particle which is accelerated by the external energy and bombarded on the target nucleus, which is a steady, which is heavy, and after the interaction it converted into the product and addition of that product particle. Okay, so on the basis of that, the scattering reaction is divided into two types, that is elastic and inelastic. See what happened in elastic scattering. When this projectile is bombarded on target nucleus, there is only scattering occurs, no exchange of energy, they are steady, just they are come together and go ahead, just like in the Rutherford experiment. In Rutherford experiment there was the gold foil where the nucleus of the gold was there, and when alpha particle is bombarded here, it gets just scattered from the nucleus, and there is no interaction between the alpha and nucleus of the gold foil. Like that reaction is called as the elastic scattering. What is elastic scattering? Elastic scattering is the interaction in which there is projectile bombarded on the target, but they are not interact any without no interaction between them, or no exchange of energy takes place. Means they lose the nucleus without loss of energy. They are not exchanging the energy, no exchange of energy, and therefore this type of reaction is called as the elastic scattering. While you are see that in second type, that is for the inelastic scattering. For inelastic scattering, what happens when proton is bombarded? When proton is bombarded on lithium, then lithium absorb that proton and become unstable. Absorb means part of energy is absorbed by the lithium and become the unstable or excited state, and again proton is interacting with the target nucleus, means projectile is interact with the target and exchange of energy takes place. This type of reaction is called as the inelastic scattering. In elastic scattering, what happened? In elastic scattering, what happened? Just they have interact with each other, but no exchange of energy, and in inelastic scattering, they exchange the energy. Okay, so you can understand that what is difference between the inelastic scattering and elastic scattering. Okay, these are the important thing that due to the representation is very important. This x is small x is the projectile, capital S is the target, and this is the capital Y is the product, and small y is the product particle. Interaction, how is the interaction? If there is no exchange of energy, elastic scattering. If there is the interaction with exchange of energy, inelastic scattering. Okay, next. Then second type of energy, second type of reaction, that is a direct reaction, in which what happen, there are two types, that is stripping reaction, pickup reaction. Stripping reaction, it is a just like a in Marathi we can say that khardun karne, means see that this is a deuterium, it has already only one proton, two protons are there, and when we are bombarding the this projectile on the copper, the already it is very weak and very small, still copper accepted the one of the proton from this deuterium and become like this, and only one proton remains, that is the proton is remaining. Okay, means when deuterium is bombarding on the copper, it accepts the one of the nucleons from the uh, projectile and become like this. This type of reaction is called a stripping reaction. Just like if some particle is there or projectile is there, which is already very small one, and the target accepted the proton or nucleons from this projectile, and the reaction is called as the stripping type reaction. Generally in Marathi we call it as the khardun karne, like that one. And pickup reaction, what is the pickup reaction? In pickup reaction, when deuterium is bombarded on the oxygen, the deuterium take the one of the proton from the oxygen and become the tritium. Like this, the reaction is called as the pickup reaction. Means in stripping reaction, target accepted or take the one of the nucleon from the projectile, or projectile loses one of the nucleons. Okay, and here in pickup reaction what happened, deuterium accepted, or you can say that gain the nucleon from the target nucleus, and become this reaction. This is called as the pickup reaction. Just like when we have a lot of chocolates, we are taking the good chocolates from the basket, like that, and the projectile can take the one of the nucleons from the target. Okay, this type of reaction is called as the pickup reaction. Next, radioactive or compound nucleus reaction. Radioactive or compound nucleus reaction. In this reaction, what happens when the reaction is not completed in a one step? See, proton is bombarded on the copper, it converts copper into the zinc, and zinc is unstable compound is here, and then after splitting, zinc become like this with the emission of one proton, sometimes two proton, neutron. In first time one neutron, sometimes two neutron. According to stability, they can produce the one proton, one neutron, like that one. Same here also, one of the reaction. When magnesium proton is bombarded on magnesium, it converted into unstable compound of aluminium, and after emission of the gamma rays, it becomes stable, and reaction is as like this. Means compound reaction is the reaction in which it is not directly formed, and it can be disintegrate the nucleus into some additional protons, neutrons, alpha particles, gamma particles. Okay, spallation reaction. The next one is the spallation reaction. This is a very interesting one. Here the induced by force additional neutron is produced. Additional neutron is produced in this reaction. Means in the reaction, when the neutron is bombarded on the uranium, then it converted into zirconium and tellurium with addition production of the neutron. Production of the neutron. Therefore, two neutrons are produced in this reaction. In the spallation reaction, the additional by force induced neutron is there in this reaction. These are the very good reactions. Next, spontaneous type reaction. These are the well-known reactions, so I am not going in detail of that. Already you are familiar with the alpha decay, beta decay, like gamma decay, where the spontaneous type of reaction takes place. There is no need of the projectile, no need of the external resources. Directly due to the instability of the nucleus, it can imitate the alpha, beta, gamma particles. Next, high energy nuclear reactions. High energy nuclear reactions means that in that reaction the energy is emitted very high, like this. When helium is split into the helium with additional proton plus pions, at that time the exchange of energy or energy emitted in the range of 150 million electron volt. See, this is the one type of new nuclear reactions in which new kinds of particles, namely mesons, are produced. Pions, mesons, like that particles are produced. And in this reaction, there is a pi, or sometimes pi plus pi 0 or minus pi. Pions are produced. Okay, means sometimes when the nucleus is split into the, or it produces the mesons like structures, mesons, pions. At that time, very high energy is used, or very high energy is produced. Okay. Addition to that, there are the photo disintegration. Means in this reaction, the induce again gamma rays. Photo means photon. Okay. Disintegration decreases. Okay. When gamma is bombarded on the deuterium, then due to the absorption of gamma, it split the deuterium into proton plus neutron. One proton plus one neutron is produced. Okay, this like reaction is called as the photo disintegration of the deuterium. When the photon gamma rays are used as a projectile to bombard on the target nucleus, then it split into the proton and neutron. Okay, this type of reaction is called as the photo disintegration. Means due to the with the help of photon, it disintegrate the target. Okay, this type of reaction is called as the photo disintegration of the nucleus. Next, that is the conservation law. These are the very important things in physics. The conservation laws are very important, and generally in physics we are considering about the conservation of mass, energy, momentum, change in spin. Generally spin we are very rarely use when we are going in detail of the nuclear reactions, or sometimes in higher level, then we can go to the conservation of spin. Otherwise we are generally at bulk state, we can consider this mass, energy, momentum, charge. Okay, charge and spin. So here are the three laws are there. It is important for the short notes. Generally, already we discussed in the earlier that what is the exam pattern. Generally, remember that in the Mumbai University, from the academic year 2020 to 23, FY theory papers pattern change. Okay, exam pattern change. There is a 20% internal, 20% internal, remember that, and 80% external. And already I have prepared one video on that, so you can go through that also, and I have uploaded on my channel. Okay, now what is the conservation of energy? Conservation of energy, conservation means what? It should be constant. Generally, algebraic sum of the kinetic energy of the projectile and mass energy of the target must be equal to the total energy of the product, that is mass energy, and kinetic energy of the ejected daughter particles and the product. Okay, remember that in the product generally what, there are the product is there and product particle is there, so their kinetic energy and mass energy should be constant. Means left side, at the left side, the kinetic energy, mass energy of the projectile and the target nucleus, which is equal to the mass energy of the and kinetic energy of the daughter particles. Addition to that, linear momentum, angular momentum. Generally, total linear momentum of the product should be equal to the linear momentum of the projectile only, because usually target is at rest, which is very important. See, this law is very important. total linear momentum of the product should be equal to the linear momentum of the projectile. Why we are not including target? Because target is at rest, therefore momentum is 0. The net angular momentum, generally angular momentum is one of the important thing, but in large scale we are not going through that. But when we are come to the uh, quantum mechanics, angular momentum is also important factor, okay, which is represented by L. And there are the two types of momentum. One is angular momentum, that is called as the orbital angular momentum, and spin intrinsic angular momentum, that is spin angular momentum, that is S. Okay, these are the two important momentums are there, which is also equal, okay, or remains constant. Addition to that, conservation of charge and okay. Generally, in the conservation of charge, conservation of mass, conservation of energy, conservation of momentum, these are the four laws are there. Okay, remember that. And now I am going to acknowledge here. I am very thankful to the principal, Dr. Ganesh Thakur sir, under whose guidance and motivation we are preparing or developing ICT teaching tools, and my colleagues, Dr. G.S. Gunda and R.D. Morbeke sir, who helped me a lot to prepare this preparation of the topic. I am thanks to all. I use the reference book as a said publication, Ashok Shrab. Thank you.